So let's first solve the previous example or previous seat work that I have assigned for you. And I think most of you have submitted this one. We'll try to check if correct by your answer. Okay. So it's a voltage divider bias circuit, and required is IE, RE, ZI, ZO, and AV. Okay. So if we try to refer to our notes table, where is it? Okay. To solve for the impedances and the gain, we refer to this part of the table. Okay. The AC analysis the table. Voltage divider bias. So for ZI, ZO, and AV. So first we need to solve also for RE to obtain those parameters. So small RE. And from the DC analysis, before we could solve for RE, we should first have performed DC analysis. So referring to the DC analysis table, we'll use these formulas under the voltage divider bias. Okay. So we have the choice to use either exact or approximate. Pwede mag-exact, pwede approximate. So if we have been using exact analysis lately, let's try now using this one, approximate. Not really sure kung saan actual na advantage yan, same amount of formula naman gyapon. Let's try, at least maiba na po. But before we could use these formulas, let's make sure that this condition is satisfied. This one. Beta RE should be greater than or equal to 10 times R2. So for approximate analysis, beta RE should be greater than or equal to 10 times R2. So beta is given 100, RE is given 1.2K. Is it greater than or equal to 10 times R2? 10 is multiplied to R2, which is given also 4.7K. So this is 1,200, 120. This is 120 kilo ohms. Indeed, it is greater than 47 kilo ohms. Okay. Satisfied ang atong condition to perform approximate analysis. So, delta. We'll use these formulas. Well, first for VB. VB is the same sa formula sa VTH kung exact. So VB is BCC R2 for R1 plus R2. BCC is given 16 volts. R2 is 4.7K divided by 39 plus 4.7K. Okay. The answer to this one is mga 1.72 volts. It's VB. Then VB will be used to solve for VE. VE is VB minus VBE. Nagyapon dito. one. So BE is BB 1.72 minus BBE of 0.7 constant. BE is 1.02 volts. Minus naman na siya. Next, we will solve for IE. Solve na si IE. IE is BE over RE. 0.02 divided by RE is given 1.2K. IE is 0.85 milliamperes. 851. Which then will be used to solve for RE. RE is 26 millivolts divided by IE. So 26 milli divided by 0.851 milli. So makancel ilang mga milli. So 26 divided by 0.851 sa mga 30. .56 ohms. So like 30.56 ohms. We could now then solve for the impedances in the gain. Muna ta sa ZI na lang. Una si ZI. ZI is voltage divider. Refer to the tables. R1 parallel, R2 parallel, beta RE. Beta RE. Ano no? Small RE ni. So CI is 1 over 39K plus 4.7 to isa no? Plus 1 over 4.7K plus 1 over beta is 100. Yeah. It's RE of 30.56. Is equal to 1.77 ohms. Kilo ohms. But ZO is approximately equal to RC. So CO is equal to 3.9K, of course. Last, voltage gain, AV, negative RC over RE. Don't forget the negative sign. RC is 3.9K divided by 30.56. Mga 127, 128, 28 na lang. So, negative 128. Unitless. Gain man siya. If we're going to place our or these values to our system diagram, it would look like this. So, muna itong system. This is now our system in question. So instead na ang circuit inside our system is this one, very complex, very complicated, we will replace all of it with only this one. One resistor, ZI. Okay. Another resistor, ZO, output impedance, and our voltage gain. It's AB times VI man is supposed to be whatever the value is here. So this is now 1.77 kilo ohms. PO is 3.9 kilo ohms. Our gain is negative 128. Muna siya ang gain sa itong amplifier. So let's just say, for example, lang. This is a very simplistic na example, but well, accurate nonetheless. Let's say, for example, our input voltage is 2 millivolts. Okay, 2 millivolts voltage. So we'd expect an output voltage of 2 millivolts multiplied by the gain of negative 128. Therefore, our VO is 256 millivolts. Negative 256 millivolts. Na-amplify atong signal. Instead nga 2 millivolts only, it's now converted to negative 256 millivolts because of the amplifier. Okay. It's that simple. So kaning note sa lower portion, this is just to give a bigger perspective to what we have calculated. Pero as for you, mo naman akong i-require, no? Taman lang dire. So after obtaining the values, hindi siya magamit. Maybe we will connect our system or amplifier to another system here, or in between siya. No? Maybe this is system 1. Our system is system 2. We'll connect it also to another system, system 3. So we know that it will communicate properly with these systems if given ang interfaces, no? Namely the impedances VI and ZO. Okay. Before I go further, any questions to how I solved this one?
Sir,
Yeah.
akong gi-use sir kay katong
Exact.
7 din bitaw sir.
Feminine. Okay lang,
Okay
may
ra po to
problema.
sir. Oh,
Pila yung nakuha
mga
ni mo
exact
nga
po
kuan.
sir.
Actually, mas exacto. No, accurate na ganini akong kuan. Pila yung nakuha nga kuan lugar? RE. Small RE.
RE sir kay 31.71.
31.71. So,
Sir.
approximately 32, no? Kung ato lang yung i-round up.
Yes sir.
Kani, kung ako ning i-round up mo, 31 man eh. So, 31, 32, dola na siya. No?
Okay
Pila
sir.
imong voltage gain lugar?
July siya sir, negative 114.16.
114? Wala, gamay, pero kana mas exact na siya actually.
Okay sir.
Mas
Ano
kuan na
yung
mo ha.
gigamit sir? Saan voltage divider ni siya sir no?
Voltage divider gyapon eh.
Ay kaning sa
Ano siya?
VB equals VCC.
VB.
Kato sir.
Kung imo i-observe, parehas siya og formula sa kuan. Parehas siya og formula sa ETH. Kaya gyapon yung formula sa ETH.
Okay.
Nag-differ
Okay, sir.
siguro sa pagkuha sa IE na. Pero for sure, no, pag-antig assurance, mas accurate ang imuhang nakuha kaysa sa kaning ako. Shortcut na ganit niya ako.
Okay,
Go,
sir.
go,
Sir,
na.
Yes,
Yes, question. Asa to?
30.59 ano kung RE, sir. Okay ra.
38?
30.59.
30.59.
Yes, sir. Okay ra, sir.
Okay, kaya na. Okay ra, kaya na. Wala problema na. Dol kaya na sa ako. So, sa kaninga part class, sa computation, dili na kita necessarily mag-agree gid siguro up to the decimal point, pero kung itanawon lang nako ang inyong flow sa solution, basta mo haom lang sa unsay expected, okay ra na, no? Okay ra na. Right? Was it clear? Any more questions? If none, pwede ko mag-proceed sa next na solve na nato, no? It's still 2 o'clock naman po. Early pa. Okay, so ako lang ni-upload, no, later for your reference, for your convenience. Let's proceed to this one. So this is another example of a design problem. Design is a problem because so you noticed ang endpoint is VCC, determine VCC for this given network, assuming that the gain is 160. So sa high, ingani ang type of actual real world problems na itong ma-encounter. Usually, kabalo naman ta, no? Kung unsa atong gusto na gain, maybe we expected or we intended our gain to be negative 160. So, given kita siya daan. So, dili given diri si BCC. So, siguro kung kuan lang, no? Bana-bana or estimate, pwede na nato ni i-plug og mga the usual BCCs like 1.5 mismo. 3 volts, 6 volts, 9 volts, 15 volts, 21 volts. Mga standard na values for BCC. And mo na yung practice ni siya. So mo tong mga given. And tanan nato kung satisfy ba ang output signal sa atong gusto. Okay. Example, gi-design na nato ni daan. Muna ni siya ang given nga circuit. And gusto nato nga mo niya yung gain. So mo niya atong signal, given dire. Gusto nato atong signal is ma-amplify to these levels. Na. So ato lang na-compute, ang manginanglan taog 160 nga gain. no? Para mo dako ang atong signal at that level. Need ni siya o gain nga 160, that's why given daan. So ang question, pilang BCC? No? So in practice, kung hindi na natin i-solve, no? Kung gadali lugar ta, sakla natin mas sa nga given nato nga battery daan or power supply. Common ones are 3 volts, 6 volts, 9 volts, 12 volts, 15 volts, 21 volts. Depende sa available. Ito na to sa output kung ganahan na ba ta. No? Kung naigo ba to atong gusto nga intended nga output. No? So, ano siya in practice or dali-dali nga method. So, if not ay time like this one, pwede na to i-compute actually pila bagid ang iyang required na BCC, no? For this amplifier to work as intended na may gain 160. So muna ang question nato karon. No, so isa ra ka buok ang atong unknown BCC ra. So given na daan si gain as negative 160 and si RO as 100 kilo ohms. So what about this one? Unsa man ni siya? Actually, class, pareha na silang duha. No? So si RO is muna usually ang given sa mga textbook, and if we'll be using the RE model, muna siya ang given sa mga textbook. Sa mga specification sheets, usually ang given is GOS, like this one. So this is straight from the specs or specs sheets. So sa relationship ni RO and GOS. So RO is actually just equal to the reciprocal of GOS, 1 over GOS. So kung given si GOS as specs sheets, and ang sa atong mga formula sheets is RO, i-divide lang nato si GOS gikan sa 1. O maka nato si ROS. Paigo nato. And the reciprocal is the same, no? GOS is of course 1 over RO. So kaya na sila. So tayo ninyo 1 divided by 100 kilo ohms. Pili ba? 10 lagi ni. Wala nagtugma ang duha ka given. So siguro itong gamiton is 10 micro Siemens. Sige lang, no? Typo error siguro na siya. Pero still, this is correct, no? Buta na ito dire. RO is the reciprocal of GOS. And GOS is measured in Siemens while RO is measured in ohms. So, mga apelyido na sa mga karaan nga scientists. Ohms is the reciprocal of Siemens. So brand ni siya sa cellphone sa una, no? Sapon ba mo ana? So based sa initial na given, 1 over 100k nato ni, no? Nato ni siyang substitute here. We'll get a GOS of 10 microsiemens. So safe siguro ni, no? Safe siguro ni nga given 10 na siya. So we'll be working with that. Hindi kayo siya magamit, no? Kay hindi kayo siya magamit kay hindi man ito magamit at RC. So, sige lang, no? Punta na nato na diha. Okay, important na sila nga mga parameters. Okay, so what do we do? Given ang gain, given ang RO. So let's start with the formula of the gain. AV is equal to negative RC over RE. Ang voltage divider man eh. Gain is given, negative 160. RC is given, 3.3K. Okay. So negative 3.3K over RE. So na to si RE. RE is equal to 20.625 ohms. This is our RE. Next, IE. Masolve na si IE dayon. IE is ano? RE is equal to 26 millivolts over IE. Constant na siya. IE then is equal to 26 millivolts over 20.625. Therefore, E is 1.26 milliamperes. One. Amperes. Okay, the next. Kung emitter bias lang ni, dali na, KVL na yung tana, pada yung CBCC. For voltage divider man, kita ka KVL diretso. If magamit o exact approach, kinangantag VTH, IETH, and RTH. Ano naman si RTH given? So, let's slide down. Oh, let's slide. So to use the exact. Di natin mag-satisfy condition. If dili mag-work, then we'll use later the approximate. No? Kung dili yun kaya. So let's use this one. ETH minus BBE, RTH, beta plus 1 RE. Given mo sa tanan. So let's use that one daw. Pero dapat ay IB. So solve natin si IB. IE is beta plus 1 IB. Therefore, IB is IE over beta plus 1. 1.261 milli divided by beta. 100. So 101. So 1.261 divided by 101. 12.48 microamperes. Right. So from the DC analysis table, IB is equal to ETH. Solve na to na RTH. Sure. 82 and 5.6. 82K parallel 5.6K. 1 over 82K plus 1 over 56, 5.6K. Johnny Dolo sa 5.6 ba? 5.24. 40 kilos. So that can that be used to solve for H IB ETH minus BBE all over RTH plus beta plus 1 RE. One equation, one unknown. No? Shift solve. Masolve na siya. 12.48 micro is equal to ETH is unknown minus BBE is 0.7 all over RTH is 5.24K plus beta is 100. So 101. RE is given 1K. Shift solve. H can be obtained. Mas mga 2.026 volts. Daog na. ETH is equal to VCC R2 over R1 plus R2. 2.026 VCC R2 is 5.6 og 82. Shift solve VCC is equal to 1.69. So kung nata exact nga function generator or power supply, pwede lang natin na ma-obtain. If wala, I think the closest answer is 32. Kaya mga fixed power supply, kay kuan man na sila. Definite na mga values. If nag-approximate ito taan ni class, ang makuha na itong answer is 30.7. So, or approximately equal to 31. Diba? Close enough. So, di kahit mabala ka, if magamit tag exact analysis or approximate voltage divider for as long as this condition is satisfied for the approximate. Okay. I think it's all here. Wala gid gani nagamit ang ano. RO or GOS. So, an example. Any questions so far?